All right, so here, basically, remember, we're still in the process of, working with trig functions, okay? Remember last time I did go through what sine, cosine, and tangent are, or how they're defined. We also had the other trig functions of cosecant, secant, and cotangent. I did give those definitions. What's nice is I also gave reciprocal identities. That's nice because, at least for me, that makes it easier to remember secant, cosecant, cotangent. Makes it a lot easier to remember those. At least I think so. For sine, cosine, and tangent, you have SOHCAHTOA, which is good. Let's say. Also remember from those identities, you can actually get all the trig functions once you know sine and cosine. You can express them all in terms of sine and cosine. All right. Okay, so anyway, let me go through another example like that. So let me go through some more examples, then we'll do some other stuff. All right. So for cosine of theta, let's assume that cosine of theta is 1 over 3. What we're going to do is we're going to figure out all the other trig functions. But we're not going to figure out what theta is. We actually don't know enough to figure out theta. And we don't have to, as you'll see. What you do want to do, though, remember, okay, is when solving these kinds of questions, you want to draw a right triangle so that this is true. That's what you want to do. And that's what I did here. So we have a right triangle, as you can see. I put theta over here. And now we need to get the side lengths so that this is true. Well, cosine of theta, remember, is adjacent over hypotenuse. So I labeled the adjacent side as 1 and the hypotenuse is 3, right? And now in this right triangle, cosine of theta is adjacent over hypotenuse. Adjacent over hypotenuse. So cosine of theta is 1 over 3. So we drew a right triangle so that this is true. That's what we're doing. And now, what about the other side, the unknown side, the one I labeled x? Okay, we want to get all the side lengths. Now, can we do that? Well, yeah, because we know Pythagorean's theorem, and that's what I'm doing here. I'm just using Pythagorean's theorem. All right. So, from Pythagorean's theorem, we have x squared plus 1 squared is 3 squared. In other words, we have x squared plus 1 squared, which is 1, is 3 squared. 3 squared is 9. So we subtract 1 from each side. As you can see, because once we have this equation, we have to figure out what x is. Okay, well, let's isolate x. Remember, that's how you solve an equation like this. So we'll get the 1 out of there by subtracting. We have x squared is 8. X squared is 8. Okay, well, if we know x squared is 8, then x has to be the square root of 8. So x is the square root of 8. In other words, oh yeah, we get this. I simplified it actually to get 2 radical 2. 2 times the square root of 2, excuse me. You only have to do that if I ask you to. So if you left this as the square root of 8, that's fine. I did go through how to simplify these, so, just letting you know. All right. So once we have the third side, in a sense, we're home free because now we just use the trig functions. So that's what we use next. So sine of theta, right, is opposite divided by hypotenuse. Opposite hypotenuse. So we have the opposite, which is 2 radical 2 over 3, the hypotenuse. Okay? Cosine of theta, right? Well, we actually knew what that was already, cosine. We had the adjacent hypotenuse. So cosine is 1 over 3. That we kind of knew already. Tangent is opposite over adjacent. Opposite over adjacent. Okay. Now, how do we get these 3 here? Well, you could use the definition, or you could do what I'm doing, use those reciprocal identities. Right? For cosecant, that's 1 over sine. If you do 1 over a fraction, remember what happens? You invert it. Right? You invert it. You, in a sense, turn the fraction upside down. Really hate saying that, but it's not precise, but in a sense, that's what you're doing. The denominator is the numerator, becomes the numerator, and the old numerator becomes the new denominator. So it flips. And you get this. Okay. For cosine of theta, right? Well, we already knew what that was. Cosecant, that's 1 over cosine, right? We have a fraction 1 over 3. Well, if you flip that, you get 3 over 1, which is just 3. Tangent of theta, right? That's opposite over adjacent. Opposite divided by adjacent. We have 2 radical 2 over 1, which is 2 radical 2. For cotangent, that's 1 over tangent, right? Meaning you do 1 over tangent, and that's just 1 over 2 radical 2. So that's what we get. Now, I did actually, if I remember correctly, I did go through some time ago rationalizing denominators, but you don't have to do that here. So, I mean, really, although I guess technically you should do that, but if you don't do it with me, that's okay. Sometimes though, you might have to do that, and again, you just basically get the radical out of there, but you multiply top and bottom by radical 2. That again, that's different, so that's a different story. Any questions on this one? Here's another one. Okay. So here I'm giving you cosecant. This one's a little different, right? Cosecant is 13 over 12. And again, we want to figure out what theta is. Now, you know what cosecant is? What you want to do, you want to form a right triangle that has the angle theta. We don't know what theta is, but you want cosecant of theta to be 13 over 12. Okay, now cosecant of theta, as we know, that's 1 over sine theta. So really what we have then, we have 1 over sine of theta is 13 over 12. We want sine of theta. Well, we can actually get sine of theta from here. Just cross multiply. Let me write it out. From here, wait, hold on. There we go. So we have cosecant of theta bear with me, is 1 over sine. this is over 1. Now, essentially what you're going to do is you're going to cross multiply. In other words, from here, you can basically, through cross multiplying, you can interchange these two sides. I mean, the 1s normally you would interchange as well. Although they're both 1s, so that's not going to do much, I guess. Here, we can actually cross multiply and get a sine of theta is equal to 1 over cosecant of theta. So we're just cross multiplying. That's really what it boils down to. I mean, there is a little bit more algebra that I'm not writing out. But in the end, that's what's going to happen, though. In the end, what ends up happening is, as you can see, you're really just interchanging these two. Let me get the laser thing. And you're interchanging these two. That's all you're doing. And you end up getting sine is 1 over cosecant of theta. We know what cosecant is, right? That's 13 over 12. Well, when you remember, when you do 1 over a fraction, that's the same, okay, as inverting the fraction. In other words, that's the same as 12 over 13 in this case. 1 over 13 over 12 is 12 over 13, right? You, in a sense, turn the fraction upside down. That's what we're doing. Okay. All right. So now that we know what sine of theta is, okay, what we can do is proceed just like before. Namely, we know sine of theta is 13 over 12. Okay. So just like before, we have to figure out, though, the unknown side. Excuse me, we have to draw a right triangle first so that this is true. Well, sine of theta is opposite over hypotenuse. So sine of theta is opposite, which is 12, over hypotenuse, 13. So this right triangle satisfies this. You don't know what this side is. That's okay. We'll figure it out. Let me just pause the recording.